Okay, in the previous video, I introduced you to the idea of a substitution instance, where we could see that a bunch of sentences are all just examples of another sentence that we introduced with the scripty letters or the meta variables. And I showed you how to identify substitution instances of basic rules of inference, including conditional elimination and disjunction elimination. And we did a little bit about how to put together cases of valid rules of inference into chains that we call proofs or derivations. For this video, I want to go through the most basic kind of derivation, direct derivation. And so this is going to be sort of the first batch of problems where you are just doing derivations, and they're all going to be of the simple sort, direct derivations. So direct derivations use the 6 basic rules. So what we saw previously is that for each connective there's an introduction rule and an elimination rule, right? And in our basic rules, we saw both the introduction and elimination rules for the and the or. We've also seen elimination rules for the conditional and the biconditional. We've not seen introduction rules for the conditional or biconditional yet, and we've seen none of the rules for negation. All of those will be involved with more fancy kinds of proofs, rather than direct proofs. So for these proofs, we are limiting ourselves to these 6 rules. All right. So in problem set 7, the first batch of problems just asks you to derive the following. And so I want to run through some of these to give you a sense of the basic procedure. So for number 1, it says A implies B and A. Those are your 2 premises. And from that, you are to infer A and B. So right now, that's all written on one line. When you do the derivation, you need to set it up like this. So you go here. You write one premise on line 1, another premise on line 2. And this time we only have 2 premises, so we go ahead and we write the word want off to the side, and then we write our conclusion. So we have the premises and we want the conclusion. Then we draw a line here and a little bar there. That little bar is called the Fitch bar, because this style of proof was invented by a man named Fitch. And so that marks the line between things that we are given and things that we infer. All right, so we've got 6 possible rules that we can use here. And so I've just put them on the sidebar. And then we just need to look at the rules in the sidebar and see what can be applied to the derivation on your left. So the one thing to think about is what connectives we're working with, because all of our inference rules are either introduction or elimination rules. So we can look at what connectives we have and see if we want to eliminate them. And when we do this, we're just going to be looking at the main connectives. So look, our premise here, our 2 premises are A implies B and A. The connective, the one connective we have is a conditional. So it's pretty clear that we're going to want to use conditional elimination, right? And it's already in the right form. You substitute A for A. So that's all really straightforward. And that means that we're going to get B down here. And so we annotate that by saying conditional elimination, that is arrow E, and lines 1 and 2. So the right column explains how it is that you get the line that you're looking at from the previous lines. So this time line 3 comes from lines 1 and 2 and conditional elimination. So now what do we do? Well, we know that the thing we want has an and in it. It's A and B. So we look over at our rules, and lo and behold, there's a rule for introducing statements with an and it is already written out with A and B. It says you need to have A on a previous line and B on a previous line. So we just apply that to lines 2 and 3, and then we can get A and B. And we're done. That was it. So that's a simple 2-line proof. We have strung together 2 rules, conditional elimination and introduction, to give us a proof. So let's try another one. So you go back here, look at number 2. Number 2 is a lot longer. It's got 3 premises, and some of them have lots of parentheses and stuff in them, but we can figure this out. We just want to write the first line as our first premise, A, if and only if D. Our second premise is C. And our third premise is this really long statement, A, if and only if D, and C implies C, if and only if B. And our want line is B. So we draw a line there, and we draw the Fitch bar. Everything below the Fitch bar is things we're figuring out on the basis of what we've been given, which is the stuff above the Fitch bar. So here are our options. Now, this might be tricky. You might look at this and say, I don't know what to do. Well, one thing to note is that we want B. There's only one place where B appears in the premises, and that's at the very end of statement 3, the third premise, right? So somehow we are going to uncover B from all of that other stuff. So we're going to be using a lot of elimination rules. In fact, we're going to want to use the conditional elimination rule to get rid of all of the stuff that is to the left of the conditional in line 3. To do that, we need actually the stuff that's to the left of the conditional in line 3, right? So notice that we've got A implies D, A if and only if D on one line, and C on another line. And then the antecedent to line 3 is the two of those things combined. So really what we want to do is combine them with and introduction. We take and introduction, we apply it to those 2 sentences, and then we write our result over there. Right? A if and only if D and C, and we justify that with and introduction in lines 1 and 2. And there's an extra square bracket there. That's just a typo. Okay. Now we can think about another rule. We can apply conditional elimination to line 3 and line 4. We bring the result over here, and we get excuse me, C if and only if B. So now we're cooking with gas. Next thing, C if and only if B has the thing we want in it. It's got that B. It also has as its main connective a biconditional. So we're going to apply the rule of biconditional elimination to it. Boom. Now where are we going to get something to work with that? Well, we actually have to look several lines up, back to line 2, to find our C. But once we do that, we can see that lines 2 and 5 work together to give us something that fits the form of biconditional elimination. And so we can write B right there. That's pretty cool. Okay. And we're done, right? So the last line of the proof is what was in our want line. That's how we know we're done. We got what we wanted. All right. So this is the rest of this problem set. And I'm going to give you a bit of a hint here. The last two are tricky. Look at number 7. 7 has a C in the conclusion, and yet there isn't a C in any of the premises. Number 6 is also weird. It's got this A or A thing. I don't know what would justify that. Well, here's a hint. When you're looking at your rules, there is only one rule that allows you to introduce a new letter, and that's OR introduction. OR introduction allows you to introduce letters that weren't in the system before. So that's an important hint.